All right, welcome to 11.3 day 2. Here's your example. Here's your problem of the day. So we got a fraction in here, but that's not going to stop us. We just know fractions mean division. To get rid of division, we do the opposite of division, which will be multiplication, but I'm getting ahead of myself. First, we got to get rid of that positive 5 because we need to get x all by itself. So I am going to subtract 5 from both sides, subtract 5, these cancel, we are still left with that fraction, x over 10, equals negative 25 minus another 5, you could write it this way, and let's see if we do keep, flip, change, and now it's negative 25 plus negative 5, which gets you negative 30. So it's going to be negative 30. Then now to get rid of this fraction, we are going to do the opposite of what a fraction means, and a fraction means division. So I'm going to do multiplication to get rid of this fraction. So I'm going to multiply by the number in the denominator, and the number in the denominator is 10. So I'm going to multiply both sides by 10. What happens here is, if this were a fraction, which is what we would be doing, these can cross cancel and turn into 1. We divide both of them by 1, so that means we're just left with x. We're left with x equals negative 30 times 10 gets us negative 300. Final answer. Okay, so that is how this works. Here's a very similar problem, and let's see if you can find the mistake. Or maybe there's multiple mistakes. See if you can find them. All right, welcome back. So let's take a look, huh? So we have x over 6 plus 3 equals 18, negative 18. They subtracted 3 from both sides, which is great. So negative 3, positive 3, negative 3, those should have canceled out. Then they brought down the x over 6 equals negative 15. Let's work that out. I think there's something a little fishy here. So if we do negative 18 minus 3, and we did keep, flip, change, the negative 18 plus negative 3, that won't get us negative 15 because now we have to add them together. 18 plus 3 should get us 21. 21. So 3, so then instead of negative 15, this is now negative 21. Now what they did, and it looks like they multiplied by 6, which is correct because those would have gone away, and then they're left with x. And now 21 times 6 should have got them negative, what is that, 126? Negative 126. All right, so you should have noticed that. So the step that they messed up was right here. Negative 18 minus 3 is not negative 15. They just did 18 minus 3 and they left it negative. That's not what you do. So hopefully you saw that was the mistake there. Moving on to today's work. We are going to be able to identify the missing length in a similar triangle. So let's see what we got going on here. Zoom out. All right, so here's our problem. It says, while playing tennis, Mr. Crowder's favorite, Matt is 12 meters from the net, which is 0.9 meters high. He needs to hit the ball so that it just clears the net and lands 6 meters beyond the base of the net. At what height should Matt hit the tennis ball? So in this example, it says both triangles contain angle A. So what they're talking about is there's two triangles. It looks like it's one triangle, but there's two different triangles in here. So they're talking about, actually a highlighter. They're talking about this triangle that you can obviously see, but then they're also talking about, let's do blue. We're also talking about this triangle. So there are two triangles on top of one another. So they're saying that both these triangles contain the same angle here, so angle A, and the right angle. So that right, they're looking at right here, they're looking at this. So remember from yesterday, last class, that if two triangles possess two of the same angles, that they are going to be similar triangles. So that this is them proving it, that angle, the measure of angle A and the measure of angle, these B and D ones, they are the same. These are 90 degrees and this is the same on both triangles, so they are similar triangles. That means we can go ahead with our problem here. So we are going to be we're going to figure out how high he needs to hit the ball. Now, remember yesterday I was saying how they are similar triangles. Well, that means since they're similar, we can actually set up, I was also throwing around the word ratio. We're going to be setting up some ratios here. And we are going to make some fractions. So I am going to take small triangle height, which is 0.9. You see that? I'm going to take the small triangle, small triangle height. So there's nowhere really for me to write here. So I'm going to take the small triangle height, so 0.9, and put it over the small triangle length, which is 6. Now I'm going to set it equal to, we're going to set it equal to the big triangle. So I'm going to take the big triangle height, which we don't know, so it's M in this problem, over the big triangle's length. Now I don't want you to be fooled. How many of you are going to tell me it's 12? I bet you most of you are going to tell me the length of the big triangle is 12. Well, I'm going to tell you, you are incorrect. They are just telling us 12 is as big as this part, but we're still missing this section. So you need to add the bottom two numbers. We have to do 12 plus 6, and that is going to get us this entire section. So 12 plus 6 gets us 18. So the length of our big triangle is 18. Okay, so now we have our ratios, our proportions set up. Now we are just going to solve for m, just like we did in our problem of the day. We need to get rid of that 18. How do we get rid of the 18? Remember, this is a fraction is just division. So we are going to multiply both sides by 18. So these will go away. Multiply by 18. All right, now you might be like, Ms. Abbott, what are we going to do? Well, we have to just multiply straight across. With fractions, you multiply straight across. That's 18 over 1. So I'm going to take 18 and multiply it to 0.9. So 18 times 0.9 gets me 16.2. Yes, you can get decimal answers. It is possible. So our answer is going to be, I'm running out of room, guys, 16.2 over 6. Now, do you think this might give us a nice number? I don't know. 16.2 divided by 6 is 2.7. So the height that he needs to throw the ball, so m equals 2.7 meters. So he needs to hit it at 2.7 meters high. Okay. So that is that. It looks like on your homework you're able to leave them as a fraction, just like here. So here's another example. These are on your homework, by the way. There's always an example written on your homework. So you take the small triangle height over the small triangle length. So in this case, the height of the baby triangle is h and the length is 8. So it's h over h equals 2 over 24. See how in this problem it shows you that the length from the the whole triangle is 24. If they just put it over here, you'd have to add like 20 or 24 plus 8. So make sure you're watching out for that. Then we got, once you multiply by 8, they just multiply the top numbers. 8 times 2 got you 16. And then 16 divided by 24. Oh, I guess we got to do 2/3. So you do it to divide. We divide, and that's what you happen. So 16 divided by 24. Okay. Let's go back. We're going to do one more, hopefully, together. Maybe. If I could see what we're recording. Yep, we can do one more. Okay. So it says a flagpole casts a shadow of 23.5 feet long. At the same time of day, Mrs. Gilbert, who is 5'5" tall, casts a shadow that was 7.5 feet long. How tall in feet is a flagpole? Round your answer to the nearest tenth. So that means we're going to be getting a fraction, or decimal, guys. So they already started setting up the fractions. We have 5.5. What number goes with 5.5? Is it 16? No, 5.5 is the height of this little triangle. So I need the length. I need the length of the little triangle. The length of the little triangle is 7.5. So I'm going to write 7.5 here. And now h is the height of the tall triangle, or the bigger triangle. Now, is the length of my small triangle 16? No, you have to add 16 plus 7.5 because 16 is only this, that's how long this is. So we're going to add 16 feet plus 7.5. So let's do that. 16 plus 7.5, oopsie. 16 plus 7.5 equals 23.5. All right. Now we need to get HO by itself. We got to multiply because remember fractions mean division. So we're going to do the opposite of that. And so we're going to multiply both sides by 23.5. That means these go away. Multiply by 23.5. Now when you do this, you're just multiplying the top numbers because remember there's a 1 under here and we're just going to multiply straight across. So 23.5 times 5.5, so when we leave that in the calculator, times 5.5 gets me 129.25. So I'm going to rewrite it over here, okay? 129 what was that, 25? 25 over 7.5. Last but not least, you just shove this in the calculator. See how I'm leaving it in the calculator? So I'm going to take this 129.25 divided by 7.5. So I'll leave that in the calculator and press divided by 7.5 equals, remember it said round to the nearest tenth? Tenth is in this spot. So it's going to be 17.2. Does 3 tell me to go up or down? If it's higher than 5, then we go up. If it's 5 or higher, we go up. If it's 4 or lower, we stay. So it's going to be 17.2. So our final answer is 17.2 feet. And does that make sense to our problem? Yeah. 17.2. It's definitely bigger. It's bigger than our shadow. No, our shadow, remember how long is our shadow? Our shadow is 23.5. So it makes sense. It would not make sense. This number would not make sense if it was like 50 feet high. It would not make sense because if this person is 5.5 feet tall and her shadow is a little bit bigger, that means our pole should have a shadow that's a little bit bigger than how tall the pole is. So remember our shadow is 23.5 feet. So our pole should not be bigger than 23.5. So you know you did this correct if our flagpole number is lower than the shadow. Okay. All right. Well, that is it for today. Let me know if you have any questions.